Hello, everyone, and welcome to one of the most exciting talks on the agenda: how air-cooled, high-performance computer data centers and Aerospike meet the Gen AI needs of 6Gs. My name is Theresa. I am JD, and I just finished a quantum machine learning PhD, and I am excited to bring you this talk. So my dissertation just won Dissertation of the Year, and my experience is in exascale high performance computing, and I worked for 10 years with Hewlett-Packard Enterprise, where I was their global chief AI solutions architect. And I actually just finished my data science PhD. The specialization was in quantum machine learning, and I actually won an award for this work in QML, and the research was actually just published. So the pipeline that the telco industry sponsored this research on was an end-to-end exascale AI pipeline, and it was specifically for building out a 6G use case, and in order to help them architect their networks for mixed reality, so AR/VR headsets, and helping them build out that infrastructure in preparation for the next generation of wireless communication networks. So a problem that they have today is classical networks. They are at the theoretical max of what they can do. And as the chip infrastructure gets smaller and smaller and smaller, that technology, it just automatically hits quantum limitation, or it just automatically reaches quantum physics. So quantum networks are going to be here whether the world is ready for it or not, and unless they can find a new semiconductor technology. So that's what prompted my dissertation. And the AI pipeline, which most of it I can't go into detail on because it's confidential, but what is interesting is they tried to do everything using a traditional ANSI-SQL storage, and I told them that the use case that they were trying to do, it was too fast for an ANSI SQL database. They needed a NoSQL database on the front end. And so the NoSQL databases that they brought to me, I told them would never scale to the speeds that they needed or the scale that they were trying to do. And I knew this from my exascale work at HPE. So I brought in Aerospike, which I know very, very well, again, from my work at HPE. And so this use case with the problem that the telecommunications industry was trying to solve is that by 2030, they estimate that there's going to be approximately 800 million, maybe more. Nobody knows. It just depends on if industry and manufacturing specifically actually adopts all these mixed reality headsets for their smart solutions. And so if you think about all the cameras that are on factory floors, they record everything. And more digital twins are starting to pick up speeds. So after 2030, when 6G or next G, whatever they decide to call it once it actually does roll out, think of a plane flying through the air. The goal is to actually fix that plane in flight using mixed reality headsets. This will eventually become a reality. In order to make that happen, you have to have an end-to-end AI pipeline capable of sub-10 millisecond speeds. This requires an ingest tier capable of nanosecond speeds. This is not your typical key value store. So this is why I brought Aerospike to the telco industry's attention. And this is also not a scale-out use case for commodity hardware. So what I found out while working at HPE is, and I found this out because COVID hit the world and all the high performance computing labs across the country were taken over by the US government for vaccine trial acceleration, was we have to, only so many databases can actually run on high performance computers. Some of them, quite literally, they just can't scale up. So these scale out databases, they can only scale out. They can't scale up when you need them to. Aerospike can not only scale out, but it can scale up. So I have been running Aerospike on high performance computers for quite some time. And I did that specifically for my PhD work. So this multi-phase pipeline that I needed to do my dissertation, it was not only for an end-to-end ingest pipeline, but it also served for a generative AI pipeline, such that we needed to be able to answer questions for theoretically, such that they would be able to tell what the quality of experience was for these AR/VR users. Because when a customer encounters a network issue, everything that hits that network for the customer is that telco's problem. Even though that headset does not belong to the telco customer, the telco vendor, to that customer, it's a vendor problem. And they're going to call that telco vendor. And so the telco vendor needs to head off those issues before the customer is even aware of it. And so I needed to develop an end-to-end analytics pipeline that could give them a number that would basically help them facilitate those issues. But executives, they don't like numbers. They like beautiful dashboards. And so I needed to create something that an executive, because execs, they're not at computers. They're on the move all the time and they carry handheld phones. I needed to create something that an executive could pull out of their pocket and be able to basically talk to their phone and say, what is the latency? Are customers happy? Is everything running good? And it would just pop up a visual, basically, so that it would have a multimodal kiosk and they could just interact directly with their phone. And so I needed to be able to translate machine learning models from numbers into beautiful dashboards seamlessly. And that's a multimodal generative AI pipeline. And so that's basically what we did throughout this process. So it's basically, in short, without going into detail, because all kinds of other people at this conference are going into the low-level detail on this for Aerospike. And I didn't use Aerospike for any of this work because Aerospike didn't even have the capability to do that when I did my dissertation. All of my graph work was done with GPUs. But it was impressive work. So I'm going to talk about solution building for end-to-end AI pipelines. And in this, solution building blocks, they allow a single design to be created, rolled up, and scaled, both in size and complexity, to accommodate the needs of SMBs, enterprises, hyperscalers, and exascale customers. My specialty are exascale customers. And if you ask what is an exascale customer, think of the top 20 to 50 Fortune 2000 accounts. Those are all exascale accounts. Solution building blocks are not one size fits all, single pane of glass. If you are looking for a single pane of glass, then that's probably not going to be something that you're going to get with a single solution HPC type of exascale system, or even high-end hyperscale system. And one size fits all, it does not exist at very, very high-end hyperscale systems. And so those are things to keep in mind. So Aerospike solution building blocks for HPC AI workloads are what we are specifically talking about in this discussion. And the following HPC AI solution building block design is what I'm presenting, and this is work that this is work that I am presenting on the behalf of people who performed it several years ago, and it was performed after I left HPE, and I only recently found out about it when I joined Aerospike just a couple of months ago, the end of March, and after I found out that it was done, nobody had done anything with this work, and I was just so excited about it because there was white papers done, there was PowerPoints created, all this external collateral that I wanted to present on it, and I'm going to rerun all these benchmarks with all the latest and greatest HPE backend storage so that we could create new solution building blocks for our mutual and joint customers to get out there because we have joint CPU GenAI customers and HPC customers with huge workloads that this would really, really benefit. Who need this? So I'm really excited to present these benchmarks that are based on confidential work that I did in my lab that I can't discuss, but these are public and I can show you these. So this building block right here, if you have a workload that falls under this criteria, please let us know, and we would be really, really happy to reach out and work with you. This falls under mission critical workloads. So these are very much tier 1 accounts. These people have very high RAS requirements. These are reliability, availability, serviceability. Absolutely sub-millisecond latency requirements, often microsecond, maybe nanosecond. Scale up and scale out could be either or, sometimes both, often both. Tens to hundreds of billions of transactions per second. This is dependent on node count. And we've got HPC network throughput requirements. And so here we're talking about you're using NUMA architectures within the frames. And then you've also got 100 gigabit E plus network connectivity or InfiniBand connectivity. I put 100 gigabit E in here simply because I'm talking to an Aerospike audience, and that would resonate. But for an HPC audience, this particular hardware, the former Superdome Flex, it's now CSS 3200. It supports InfiniBand as well as other architectures, network architectures as well. And then TCP/IP2 InfiniBand requirements. So this is one of the very few architectures on the planet that I'm aware of. It may be the only one still, where you can ingest directly from. So you can egress TCP/IP, and you can ingress TCP/IP, and you can egress InfiniBand. This is why I love Superdome Flex, now CSS 3200. And it's because it allows me to pipeline. So I can ingest using Aerospike at incredibly high speeds, and I can egress directly to my supercomputers, doing all my GPU deep learning algorithm work on the back end for all my high performance computing engineers. So this is phenomenal flexibility, and people often fail to realize what we have here. So this is kind of the gold star for me on this platform. And then flexible storage options. So this is another favorite of mine here is I have the ability to use Flex as not only compute only, but you can use it for local NVMe. You can use the ScaleFlex integration. ScaleFlex is a third-party provider, which Aerospike works very closely with to optimize its drive drives for for Aerospike performance, and then it's optimized even further for Superdome Flex for all of those core count threads. It's performance like you can't even imagine, and then we have the ability to just separate this and distribute it for massive, massive scale on both compute and storage. So we have Superdome Flex doing what Superdome Flex does best, which is compute. And then we have HPE storage doing what it does best. So we've got the Electra's 4000 series doing petascale storage on the back end. And that's what I used to do in my lab when I was HPE, where I ran one of the first, in fact, I think it was the first petascale lab in the company. And that was the exact design that I ran. So what you're going to see here are the benchmarks. Again, I did not run these benchmarks, but it was a collaboration between HPE, ScaleFlux, and Aerospike. And it was run several years ago now, but it was run on the predecessor to the CSS 3200, the Superdome Flex. It's been rebranded CSS 3200, same hardware, just bigger and better. So the Superdome Flex was the former Cooper Lake chips, and now the latest and greatest is the new Sapphire Rapids chips. But I'm not going to go into the architecture. I leave that to HPE. They do it best. But this particular benchmark, it was Aerospike 5.7. And it ran with ScaleFlux CSDs, which are FPGAs. But ScaleFlux, to call it an FPGA is a disservice. All I can say is wow. So hats off to ScaleFlux. And so again, these three companies, what they do, and I like to speak in the third person because I will always think of myself as an independent contractor. Aerospike, ScaleFlux, and HPE, they came together and they tore this design apart, and they collaborated night and day for weeks on end, months on end, 9 months in total, to just suck all the performance they could possibly get. There is absolutely no external networking in this design. And the only thing that they did is they tested a key value store at sub-millisecond speed. And they were looking for billions of transactions per second. And so what they got here is they tested 25 billion unique key values on a single Superdome Flex system, so one frame, and replication was enabled. We had strong consistency disabled, and they achieved end-to-end 400 nanoseconds of end-to-end transfer times. And so you're talking about 800 cores, basically 30 terabytes of RAM, and then ScaleFlux drives, which were perfectly tuned to Aerospike. And yes, so very, very impressive. So on average, and I will let people digest all of this on their own. I'm not going to go through all the nitty-gritty details here, but on average, approximately 2.8 million Aerospike transactions per second in a single Superdome Flex system with 8 sockets and 30 terabytes of RAM running on ScaleFlux Aerospike drives. And again, that's just using internal Superdome Flex Unilinks. So this is what a pipeline system looks like. So this is built for keeping everything within the frame, scaling it up, and keeping as much network internal to the frame as you possibly can, and designing it that way. So it's built for high performance computing, and when we design it to keep all the networking internal to the system, you truly can optimize everything for performance. So the types of use cases that we do this for are specifically for high performance graph, high performance generative AI, and pretty much everything that would be version 7.1 Aerospike use case. So they would be graph, they would be vector, they would be generative AI, optimized GeoJSON use cases for Elasticsearch, and then we have all the additional benefits of Aerospike v7, which would be our optimized memory format. Which allows Aerospike doesn't use much memory. So this is why the system is absolutely perfect, because Aerospike is computational heavy. Anybody who's ever run AS Bench knows that it takes almost no workload to completely crash any vendor's box. So with Superdome Flex, the latest and greatest system, you've got 16 processors on just a single frame. We've got 16 processors, 960 cores, 32 terabytes of RAM, 1900 threads, and Aerospike would just go nuts with that. Just have so much fun with that. It's not going to use much RAM, so somebody like me, who's a pipeline developer, we know exactly how to architect that for something that is somewhat RAM intensive, but isn't going to leverage the CPU quite as heavily. So we look for that marriage, that perfect balance, and that is exactly how you leverage these types of systems. And so, in that case, you're leveraging the NUMA architecture through and through, and you still, again, in these designs, how they're made, you have the networking still able to be used for the client traffic. So for all of your internal traffic, and then you can still use your InfiniBand for external deep learning. So getting everything out offload. And so the next generation that we're looking forward to getting into a test bed, this is the latest and greatest technology that you're looking at. So you saw the old Superdome Flex that we just tested in the test bed, and the new version with Sapphire Rapids is got a much smaller footprint, that 280, and so it would go from one frame to 5 frames, where we would have 80 processors and as many as 9,600 frames and 2 petabytes in a single footprint. So if we had internal storage, but with the Electra 4140s, it would be a much cheaper storage option, and just one of those would have 2 petabytes in a single unit. So it would make much more sense to do a distributed S3 compliant storage format, which all kinds of vendors could tap into. And so this is what that scale out system would look like. So end-to-end pipeline solutions for public and private sector. Again, this is an HP solution. I just came from HP Discover, so this was very easy for me to put together. Aerospike is vendor agnostic, so I definitely want to put that forward. This can be built for anyone, but this is specific to Superdome Flex here, this particular design, simply because Flex, no other vendor can do pipelining. And I am an AI pipeline developer. So I absolutely love HPE's Superdome Flex because I can pipeline with it like nobody else. And I can build an entire high-speed pipeline that can push tens of gigabytes per second to my supercomputing cluster, whether it's Cray or whoever else is out there, and I can do it all with 1 frame or up to 5 frames. It doesn't matter, and so this is great. So we have everything from the far edge or the tactical computing edge, if you're federal. And then we've got our edge line, which is very high performing and ruggedized. And then we've got the Electra 4110, which is dual purpose. It can be scaled out. If you need it to be scale out, it's basically a DL360. But it can also be storage. And then we also have the Electra 4140, which is what I tend to pair the CSS 3200 with, because I don't often use internal storage in that CSS 3200. It's just not cost efficient. So I like the most cost optimized approach when I put these solutions together. Again, I typically develop for hyperscalers that are on the fringe of exascale, but most often it's true exascale designs. I do distributed designs, which are CSS 3200 with the Electra 4140s. And so for that, it's Electra 4140s for dense storage, which is AWS 3 compliant storage, and then Aerospike would be doing S3 backups off to that, and then the HPE CSS 3200 would be my full-fledged pipeline, whether it's a graph RAG pipeline or whatever I'm doing for high-performance computing simulations. And then on the front end, I would be doing Aerospike scale out on the Electras. I would have a smaller, more of an inference tier pipeline on my edge lines that would be a smaller footprint of what would be on the CSS 3200. And then I would just be running raw inference models on those, either raw inference or pure Aerospike ingest, and then doing XDR back to those Electra 4110s on those edge lines, or the ProLiant Mini. So that's typically how I architect these end to end, and I use ScaleFlex in as often as I can when milliseconds matter. So when milliseconds matter, I leverage the appropriate gear, and then for federal, when I have to harden everything, so when I have to take the zipper so when I have to take the secured and the secret and the top secret networks into account, you definitely put the right hardware in there as well. So I like to use appliances for that, and so I certainly interfuse into the mix, and then we also run in cloud as well. So I think that's the only last thing that I need to mention here is Aerospike does run in all major cloud providers and the government cloud providers, and we do also support GreenLake, So certainly let me know if you are interested in doing a beta trial with Aerospike on Flex, and if you have any questions on any of their solutions, or if you are interested in doing POC with Aerospike on any of the solutions that you've seen me talk about here today with any of the HPE offerings. Thank you again. I sure appreciate your time, and I look forward to meeting and working with you all in the future.